So this is the previous chapter work here that you need to do by yourself. Please take a screenshot of this one.
Yes, ma'am. Done, ma'am.
Take this one also.
Okay. Done, ma'am.
Done. Okay. So these are the two topics here. Two worksheets are there that you need to do by yourself. Some of the worksheets that prepared by me only. Okay, please do it. Whenever you can see, yeah, I'm free now. I can just do the work. You can do that. Okay.
Yes, ma'am.
Now come to the chapter that's all about the whole numbers. So the whole numbers start from the natural number, even number, odd number. So these different concepts are there that we need to cover in the whole numbers chapter. So do you aware about this, right? In the previous session,
Yes,
did you? I know about this chapter. Yes
yes,
or no?
yes,
Yes.
ma'am.
Just all about this one only. So here we can see. Now first, the concept is all about natural numbers here. So counting numbers for the example 1, 2, 3, 4, 5, 6, and etc. so on are known as the natural number that starts from one number. That
Yes.
start from one number and endlessly they are going like endless so on. So that is called as a natural numbers that start from one number.
Yes.
Whole number means that start from zero number. The
Yes.
natural numbers along with zero form, the collection of whole numbers are called as a whole numbers that start from zero. All natural numbers are whole numbers. Yes or no?
Yes, ma'am.
All natural numbers are whole numbers. But all whole numbers are not natural number. Yes or no?
Yes, ma'am.
For example, all whole numbers are not natural numbers. Yes or no? Yes
Yes,
only. For
ma'am.
example, zero only. Zero will not come in natural numbers, right? So that's the
Yes,
thing
ma'am.
I'm asking you here. So all whole numbers are not natural numbers. Okay, but all natural numbers are whole number because this whole number from zero to so on, everything is covered up. Okay, so
Yes,
that's the thing he is explaining here. Successor of whole number. Here we know what is a successor here.
ma'am. The number, when you next to the number, like add one.
Yes, perfect. So if we add 1 to a whole number, then we get the next whole number, which is known as its successor.
Yes, ma'am.
So for
Yes.
example, successor of 0 will be 1, successor of 1 is 2, successor of 2 is 3, successor of 4 is
5,
good, successor of 6 is
7,
successor of 9 is
10.
yeah. So like that, it's called as a successor of whole number. In the same way, if we have a successor, we have a predecessor also. So predecessor. What is a predecessor, dear?
Minus 1, ma'am.
Yes, perfect. So one less than a given whole number is known as its predecessor. For example, predecessor of 1 is 0, predecessor of 2 is 1, and the predecessor of 3 is 2. And a whole number 0 does not have its predecessor. Because the before 0 we can't see any digit, right?
Yes, ma'am.
And we
In
can't,
whole numbers, then there's no digits.
what dear?
In whole number, there's no digit before 0.
Yes, dear. And we can't go to the minus digit also, right? So
Yes, ma'am. Then
because of
it'll
that
count as
only.
integers, right, ma'am?
Yes. It will come under the integers. Good, dear. So whole number 0 does not have a predecessor. Now tell me, what is the predecessor of 5?
4,
20.
19.
Very nice. So this is called a predecessor. Now we need to know about some of the properties of addition. Some of the properties are there for addition. So those are, we have a various properties of addition of whole numbers. Okay. So one is a closure property of addition, commutative property of addition, additive property of a zero, associative law of addition. Please take a screenshot of this.
Yes, ma'am. Done, ma'am.
Okay. Now, So first property is all about closure property of addition. What is this? If we add two whole numbers, then the result will be a whole number. Let us see some examples. So here we can see add 5 and 7, check if the sum is a whole number or not. So simply add 5 plus 7 is equal to 12. Yes, 12 is a whole number. Simple only, yes?
Yes, ma'am.
So it is called as a closure property of addition. Other example is also there. Add 15 and 12, check if the sum is a whole number or not. Yes, 15 plus 12 will be 27, and the 27 is a whole number only. Perfect. Till here,
Yes.
perfect only. Now move on to the second concept. That's all about commutative property of addition. So what he's saying in this concept, if we add two whole numbers with different orders, then the result sum will be remain same. How it comes? For example, a plus b is equal to b plus a. So let us see some example here. So check if 7 plus 8 is equal to 8 plus 7 or not. Same only, right? 7
Yes.
plus 8 is equal to 15 and 8 plus 7 will be 15. So we can see 7 plus 8 is equal to 8 plus 7 only. This is
Yes.
the one example. Other example here, what he is saying. Check 12 plus 13 is equal to 13 plus 12 or not. Equal only. So here we can see 12 plus 13 will be 25 and 13 plus 12 will be 25. Thus,
Yes.
12 plus 13 is equal to 13 plus 12. Okay. The two concepts are done. So closure property of addition, commutative property of addition. Now
Yes.
come to the additive property of zero. So sum of any whole number and zero is the number itself. Some example here we can see 5 plus 0 will be is equal to 0 plus 5 is equal to 5 only, right? If
Yes.
we add 0 with 5, yeah, 5 with 0, we get 5 only. So no use of 0 there. Again,
Yes.
here also 12 plus 0 is equal to 0 plus 12 is equal to 12 only. There is a no use of a 0. We get the digit
Yes.
that's the main thing. Yeah. Now come to the last concept. That is all about is associative law of addition. So how it comes? In addition of a whole numbers, the manner of associating the numbers does not affect the sum. So for example, here you can see a plus b in bracket, out of that bracket plus c is equal to a plus in brackets b plus c. So let's consider some examples. So here find the sum of 5, 8 and 10. What he is doing here? First, let's consider 5 as a EA, 8 as a B and 10 as a C. He put this thing in this formula. 5 plus 8 out of that bracket 10 is equal to, so what he get? 8 plus 5 will be 13. So 13 plus 10 here, so 23.
23.
If he put the same thing in this formula, 15 in brackets 8 plus 10 is equal to 23 only. So clearly we can say 8 plus 5 plus 8 in brackets out of that plus 10 is equal to 5 plus in brackets 8 plus 10 is equal only. Okay, this is one of the example of associative law of addition.
Yes.
Now come to the subtractions. So properties of subtraction. So here we have some of the properties of subtraction that we need to cover. We have a various properties of subtraction of a whole number. So first, what we have done here he is discussing about four properties: closure property of addition, commutative property
Yes.
of addition, additive property of a zero, associative law of addition. So fourth thing is covered here in this slide itself. Then he is coming to the properties of subtraction. Addition is done. Now he is coming to the subtraction. So we have
Yes,
a
ma'am.
various property of subtraction of a whole numbers. For example, see, first property, if a and b are two whole numbers, such then a greater than b or b a is equal to b, then a minus b is a whole number. Otherwise, subtraction is not possible in whole numbers. Yes or no?
Yes, ma'am.
Yes or no. I want that answer. Perfect. Property two. Here, if a and b are two whole numbers, then in general, a minus b is not equal to b minus a. Yes or no?
Yes, ma'am.
Why? If, for example, 5 minus 8, 8 minus 5. Both are
Yes,
equal
ma'am,
or
they
not?
both are different.
Because
5
in one
minus,
thing we get in front of the digit, we get minus, right?
yes, ma'am, 5 minus 8 is minus
Yes.
-3.
It's getting in a negative way. So because
Yeah.
of that only, if A and B are two whole numbers, then in general, A minus B is not equal to B minus A.
Yes, ma'am.
Third property. If A is any whole number, then A minus 0 is A, but 0 minus A is not defined. Yes or no?
Yes, ma'am.
Good. Fourth one also, if A, B, C are three whole numbers, then A minus B minus C is not equal to A minus B minus C. Can you put sum of the number? Take any number, put
Yes, ma'am.
both of them in this formula and just tell me it is possible or not.
Yes,
And
ma'am.
just show that to me.
Yes, ma'am.
Hmm.
I'll take 7, 8, and 9. So
Hmm.
7 minus 8, I mean 8 minus 7 is 1. Then 9 minus 1 will be 8 again. But then if you put then 8, but then b minus c, which is 9 minus 7, will be 2, and then 8 minus 2 will be 6. So they are not the same.
Good. I just want to explain you in the board itself, but you have given a perfect answer. Good only. Good, dear. So what you say, it's not a equal. Okay. So it's all about the properties of subtraction, dear. It's all about the properties of subtraction. First one is addition done. Second is the property of subtraction is completed. Now move on to the third concept. It's all about properties of multiplications. So just take a screenshot of this one also, please.
1 sec, ma'am. Done, ma'am.
Good. Now take a screenshot of this one also, please.
Done, ma'am.
Now, properties of multiplication. So we have various properties of multiplication of a whole number. For example, first one, closure property of multiplication. Second one, commutative property of multiplication. Third one, multiplicative property of a zero, multiplicative property of one, associative law of multiplication, distributive law of multiplication over addition, distributive law of multiplication over subtraction. So these all are the properties of multiplication. So you will get around a 1 to 2 number of questions regarding these properties. Okay.
Yes, ma'am.
Now, first, it's all about closure property of addition, multiplication. Here, start from the first property. Okay. So, if A and B are two whole numbers, then product of A and B is also a whole number. Let's see some of the example. For example, see, product of 5 and 7 will be 35. So, 35 is a whole number only.
Yes,
First,
ma'am.
what we have done in the addition, the same thing here also, it follows.
Yes,
Product of 8 and 11 will be 88. So 88 is a whole number. Next, commutative property of multiplication. If A and B are any two whole numbers, then A multiplied by B is equal to B multiplied by A. Equal only, right? So let's
yes.
see some of the examples. So let's check if 3 multiplied by 5 and 5 multiplied by 3 is equal or not. If we
Yes.
multiply, we get 15 only. So
Yes.
thus 3 multiplied by 5 is equal to 5 multiplied by 3. Other example also given here. Check if 5 multiplied by 15 is equal to 15 multiplied by 5, or yes or no. So
Yes.
if we multiply it, we get 75 only. So it is equal. Okay.
Yes, ma'am.
Multiplicative property of 0. Any whole number multiplied by 0 gives the product 0 only. Yes or no?
Yes, ma'am.
So 5 multiplied by 0 is equal to 0 multiplied by 5 will be 0 only.
Yes, ma'am.
Now, multiplicative property of 1. So any whole number multiplied by 1 gives the number itself. Yes or no? 7 multiplied by 1
Yes,
is 7 only. 1 multiplied by 7 gives 7 only. So the multiplicative property of a 0, if we multiply with 1, gives the number itself. Okay, dear? Now
Yes,
move on
ma'am.
to the next concept. It's all about associative law of multiplication. So if A, B, C are any whole number, then A multiplied by B in brackets multiply C is equal to A multiply in brackets B multiply C. Let's see some of the example here. In the same way, he put 4 in place of A, 5 in place of B, 6 in place of C. So the same way he's doing, he's getting the same thing, 120 only.
Yes, ma'am.
Both the way, 120. So it's equal
Yes,
only.
ma'am.
Now come to the distributive law of multiplication over addition. Here see.
Yes, ma'am.
If A, B, C are any whole numbers, then A multiplied by, in brackets, B plus C is equal to. So I just want to ask you one thing, dear. Are you
Yes, ma'am.
aware about this concept?
Yes, ma'am.
Okay,
I
dear. So
studied
because
it
of that
long
only,
before.
yeah, because of that only, you are just getting me in perfect way. Good.
Yes.
So for example, let's see here, 4 multiply 5 plus 7 is equal to, he's just getting a chain. 4 multiplied by 5 plus 4 multiplied by 7. So the
Yes.
same way he's getting the answer of 48 only.
Yes, ma'am.
If he do in this way, the second way, he's getting the same answer 48 only. So it's equal. Okay.
Yes.
Now here, if we do here, we done a plus here in this point. Here
Yes.
he done a minus in this point.
Yes, ma'am.
So A, B, and C are any whole numbers, then A multiply B minus C is equal to A multiply B minus A multiply C. He put here in the same way, so he getting the same answer, 20 only. In the both things, he getting 20 only. So yes, it's
Yes, ma'am.
possible. Now, the first one, addition done. The second one, subtraction is also completed.
Yes, ma'am.
After that, a multiplication also done. The product is done. Now, the final one, it's all about the division.
Yes, ma'am.
Okay. We have a various properties of multiplication of a whole number. So first one, division by 0.
Yes, ma'am.
0 divided by natural numbers. So first, division by 0. If A and B are whole numbers, then A divided by B is not always a whole number. So let us
Yes, ma'am.
consider. Yes, let us consider 5 divided by 0. Clearly, we must find a whole number, which means multiplied by 0 gives 5. We are sure that no such number can be obtained, hence we conclude that division by 0 is not defined. Okay.
Yes, ma'am.
Now, 0 divided by natural numbers. So if we divide 0 by any natural number, the result will be 0 only. Let's take some example. If here we can see, no, 0 divided by 4, we don't consider the denominator figure. We consider only numerator figure, 0 only.
Yes, ma'am.
Okay, 0 divided by 6 will be 0, 0 divided by 8 will be 0 only. So I want to take a screenshot of this one also, please.
Done, ma'am.
Okay. So all about this one. Thank you so much, dear.